In a group project to clean up a local park, how can participants coordinate efforts and ensure everyone contributes and benefits? When you're making turn-based decisions, how do you optimize your output? Economists use game theory to make decisions in many instances, including when you're making choices based on others' choices. I'm Yana Gallen, assistant professor at University of Chicago's Harris School of Public Policy, and this is Economics for Everyone. In game theory, there are always three key elements at work. Players, those who are involved in the game, choose a strategy to interact with others and get a desired payoff, which is what each player will get at the end of the game. In simultaneous move games, these choices are made at the same time. There are other games, however, that have an added element, the order of play. Players make decisions in a specific order. An extensive form game is a representation that specifies the order of play in a game. Imagine you and a business partner open up a surf shop. You're both deciding whether you'll work at the shop that day or take the day off and surf. Your payoffs depend on the other's decision. In this example of an extensive form game, however, you make your decision after your coworker. Just like in chess, where you observe the other player making a decision, and then you make a decision in response, and so on. Extensive form games require richer strategies than those of simultaneous move games. You can see in the payoff matrix the result of the different strategies. You'll see in the matrix that we've placed a dollar amount on surfing to capture the benefits that you receive from going surfing. This will allow us to compare the benefits of working with the benefits of surfing. In your surf shop, you both receive $400 in net benefits if you both work. However, if you take the day off to surf while your coworker works at the shop, you receive the benefits of the business being open and the benefits from surfing. Let's suppose you make the first decision whether to work or surf, and then they must decide after viewing what you did. How should you go about this decision-making process? When it comes to sequential decisions, we use a game tree. A game tree is an extensive form representation of a game. Extensive form games introduce a sense of timing that doesn't exist in simultaneous move games. Following the game tree for the shop, you see that your coworker makes their decision, which places you at one of two scenarios. Then your decision will determine the final node. You know that in the end, your coworker is going to make whatever decision will maximize her utility. So you know what she'll do in response to the choice that you make. And you need to consider this when making that first decision. We call this way of thinking backward induction. Backward induction is the procedure of solving an extensive form game by considering the last mover's decision in order to deduce the decisions of previous movers. In other words, given the last mover's decision, we then consider the second to last mover, and so on. To use backward induction in our example, you must first consider the decision node at the end of the game. Let's take the node where you decided to work. This means that your coworker was deciding whether to work or surf, knowing that you decided to work. Accordingly, your coworker is deciding between a payoff of $400 if she also works, or $500 if she surfs. So in this case, she will decide to surf because she receives $100 more net benefits. Given her decision, your payoff will be $300. Similarly, suppose your coworker is making a decision at the node where you have decided to surf. Using the same thought process, you can see that in this case, she'll decide to work. In both cases, she makes the decision where she cannot be better off by changing her mind. Knowing how your coworker will strategize, how they will think through their own decisions is important. If you know how your coworker will respond, you can make your decision knowing how she will respond to each of your actions so that you can get where you want to go. In this situation, we're assuming that your coworker will want to maximize their net benefits. Given that, you know you should surf because that will maximize your net benefit as well. This is a very simple example, but the same logic applies to games where more decisions are made sequentially. Notice the equilibrium that we came to in our example is less favorable to your coworker. Such sequential games feature a first mover advantage if the first mover earns more benefits than the second mover. In other words, a game has a first mover advantage when the first player to act in a sequential game gets benefits from doing so. Let's say your coworker wants to take back the first mover advantage. Is that possible? One thing they could do is threaten you with doing an activity if you make a certain choice. In this case, that doesn't make much sense because you know that they'll always choose the highest payoff for themselves. However, this threat works if they can make a credible commitment. Commitment refers to the ability to choose and stick with an action that might later be costly. In this case, a commitment could be something as simple as throwing their keys into the ocean so they can only work if you work. Given that commitment, you are now forced to reevaluate your decision. Interestingly, from this example, we get some insight into human behavior. If you can commit to punishing bullies, you likely won't get bullied. This suggests that vengeance and reputation may be supported in part by game theory. Game theory allows us to consider situations where we have to make decisions based on the decisions of others in a sequential manner. This structure gives us insights into many situations, such as negotiations, whether it be with your sibling or between governments. Game theory is another tool you can use to make choices, because economics is for everyone.